All right, so right now I want to go over the gas laws that you should have read through last week or the beginning of this week that are in the PowerPoint. So I'm just going to go and write the equations on the top and talk about each of them a little teeny tiny bit before I move into the combined gas law. So essentially, Boyle's law tells me when temperature is being held constant, the initial pressure and volume is equal to the final pressure and volume. Now, if we're looking at Charles's law, what that's going to tell me is if pressure is held constant, my V1 over T1 is equal to V2 over T2. This could also be initial and final. I just like to use ones and twos. Then Gay-Lussac's law tells me if volume is being held constant, my initial pressure over temperature is equal to my final pressure over temperature. Now, you should have done a few questions that involve these things. Now, if we're looking at different types of problems, if it tells you that temperature is being held constant, that's how you know you're going to use this equation, or pressure is being held constant, you're going to use this equation. Now, rather than having to remember three separate equations, we can actually put all of these three equations together in one, and that's what we call the combined gas law. So the way I like to remember this is the potatoes and vegetables are on the table. And that is equal to the potatoes and vegetables are on the table. So essentially what you can do with this equation is you can look at it, and whatever's being held constant, you can just cover it. So you end up with that equation, or if we're covering up our volume, you end up with that equation, cover up, there goes my calculator, your pressure, you end up with that equation. So you have all of them in this one easy equation. Now, sometimes there's not something being held constant and we're changing all of the variables, and when that's the case, we just plug it all into this equation. Now, what I want you to remember is that temperature needs to be in Kelvin. So if we gives you temperature in degrees Celsius, we're going to add 273. Now, I know in class we were using 273.15. I want you just to use 273. Let's keep it simple here. And that equals your temperature in Kelvin. Pressure, volume can be in different units as long as they're the same on both sides. So if pressure is given to you in atmospheres or it's given to you in millimeters of mercury, you can use that as long as your initial and your final pressure are in the same unit. So we're going to do one sample problem where we're going to use the combined gas law. So this problem right here says the initial temperature of a 1 liter sample. Ooh, don't we just love word problems? So I have my pressure, temperature, volume, so 1, 1, 1, and my pressure, temperature, volume. This is going to be our easiest way to break these questions down, because even if it tells you volume's being held constant, then we just don't use it. So my initial temperature of a 1 liter sample, so 1 liter is your volume, so we have 1 liter, is 20 degrees Celsius. So right away, just so I don't forget, I'm going to change that to 293 Kelvin. The pressure is decreased from 720 milligrams of mercury to 360 millimeters of mercury. So starts, finishes. So that's my pressure. So I have 720, which is decreased to 360. And the volume increases to 2.14 liters. What was the change in temperature? So this one has a little extra step because we're looking for the change in temperature. In order to solve for that, we have to figure out what my final temperature would be. So, I have all my variables that I need. We're just going to plug them into our equation. So, I have 720 times 1 over 293 equals 360 times 2.14 divided by T2. So I'm going to walk you through a little bit of this algebra. I'm going to move this up. So I have 720 times 1 divided by 293. It's going to give me 2.46 about. So 360 times 2.14 is 770.4. Over T2. Now, in order to solve for T, remember, I'm going to multiply both sides by my T2. Cancels out. You end up with 2.46 equals 770.4. Get my temperature by itself. And you have the final temperature ends up as 313.51 K. Now, just as a reminder, the question asked you for the change in temperature. So, if my initial temperature was 293 Kelvin and my final temperature was 313 Kelvin, just do 313.51 minus 293, and you can determine that your temperature increased by 20.5 Kelvin. Now, not all questions are going to ask you for a change in temperature. However, that's why it's very important to read through the word problems to figure out what you need. Now, your first set of problems are just asking you to solve for one of these variables, whereas the next page is kind of set up in a word problem kind of situation. So feel free, do them all today, spread them out over the next 2 days or so, and let me know if you have any questions.